Good day, ladies and gentlemen. Today, we embark on an exciting challenge, tackling the AS Level Theory Paper 1 from the Cambridge Information Technology October-November 2024 series. Let's dive in and conquer it together. Question 1A. Explain what is meant by a hierarchical database management system. A hierarchical database management system, HDBMS, organizes data in a tree-like structure, similar to the company's staffing structure shown in the diagram. In this system, data is arranged in levels, where each record has a single parent and may have multiple child records. For instance, in the given diagram, the managing director is at the top level, followed by directors, departments, and workers at subsequent levels. This parent-child relationship is a key feature of hierarchical databases, ensuring that data flows logically from the top down. Such a structure allows for efficient data retrieval when queries follow the predefined hierarchy. For example, accessing all workers under a specific department would involve traversing from the department node to its child nodes. However, this system can be rigid, as it requires well-defined relationships, making it suitable for scenarios like the company's staffing organization, where data naturally fits into a hierarchical format. Question 1B. Describe how the company's hierarchical database would be used to store all staff records. The company's hierarchical database would store all staff records by organizing them into a tree-like structure, reflecting the hierarchy of the staffing chart in the diagram. At the top level, the managing director would be the root node. Below this, director nodes would represent each director overseeing specific departments. Each director node would link to child nodes representing the departments they manage, such as Department A, B, C, and D. At the lowest level, the workers would be stored as child nodes under their respective department nodes. Each worker's record would include their personal details, position, and other relevant data, linked to their department for easy access. This structure ensures that relationships between staff, departments, and management are preserved, allowing efficient retrieval of information, such as finding all workers in a department or tracking the reporting chain from a worker to the managing director. Question 2. The quality of information can affect the usefulness of decisions made by businesses. Describe how the following factors can affect the quality of information and the quality of the decisions made. The age of information refers to how current or up-to-date the data is. If the information is outdated, it may not reflect the present situation, leading to decisions that are based on obsolete or inaccurate assumptions. For example, in a business setting, relying on last year's sales data to predict current market trends might result in incorrect inventory levels or missed opportunities. Up-to-date information ensures that decisions align with the latest market conditions, customer behavior, and operational changes, leading to more effective outcomes. Relevance refers to how closely the information aligns with the specific decision or problem at hand. Irrelevant information can distract decision makers, wasting time and resources, or leading them to focus on unimportant factors. For example, when deciding on a marketing strategy, information about production processes might not be useful. High-quality, relevant information ensures that decision-making is focused, efficient, and tailored to achieving specific business goals, improving the likelihood of success. Question 3. Control technologies can be used in traffic management systems. Evaluate the use of control technologies in traffic management systems. You must identify specific control technologies and evaluate their use in towns and on motorways. Control technologies play a crucial role in modern traffic management systems, improving efficiency and safety. In towns, adaptive traffic control systems adjust signal timings in real time, reducing congestion, while ANPR and CCTV enhance enforcement and monitoring. However, urban implementation faces challenges such as high installation costs, complex traffic patterns, and privacy concerns, particularly with surveillance technologies. On motorways, control technologies like ramp metering and variable message signs, VMS, are effective in managing traffic flow and providing real-time updates to drivers. Vehicle detection systems improve safety by enabling swift responses to incidents. Despite their benefits, these technologies depend heavily on driver compliance and can be less effective in adverse weather conditions. The high cost of large-scale deployment also presents challenges. Overall, control technologies significantly enhance traffic management when deployed appropriately. Urban areas benefit from systems tailored to diverse traffic types, while motorways require scalable, weather-resilient solutions. Balancing technology integration with cost, privacy, and environmental considerations is essential for maximizing their impact. Draw a program flowchart to represent an algorithm that does the following. 1. Inputs an integer value. 2. Repeats the input process until 20 values have been entered. 3. Outputs the largest value and the average of the entered values at the end. This program is designed to process a set of 20 integer values entered by the user. It starts by initializing a counter to track the number of inputs, a variable to accumulate the sum of the inputs, and another variable to store the largest value, initially set to -1, assuming all inputs are non-negative. Within a loop that runs 20 times, the program prompts the user to input an integer, adds this number to the cumulative sum, and checks if the current number is greater than the largest value recorded so far. If it is, the program updates the largest value. After processing each input, the counter is incremented. Once all 20 numbers have been entered and processed, the program calculates the average by dividing the total sum by 20. Finally, it outputs the largest value among the inputs and the calculated average, providing the user with a summary of their input data. I have also included a pseudocode solution to the same problem, though it was not required for the exam. A pseudocode is an informal, text-based representation of an algorithm that uses plain language to describe the logical steps required to solve a problem. It resembles programming logic but avoids the strict syntax of any specific programming language, making it flexible and easy to understand. In contrast, a flowchart is a graphical tool that uses standardized symbols like ovals, rectangles, and diamonds to visually represent processes, decisions, and the flow of control in an algorithm. Both tools are used to design and document processes but differ in their approach and audience. Pseudocode is concise and developer-friendly, while flowcharts are more intuitive and accessible to non-technical stakeholders. Pseudocode serves as an alternative to flowcharts by focusing on the logic rather than the visual representation of a process. It is quicker to write, easier to modify, and aligns closely with programming languages, making it ideal for complex or detailed algorithms. Flowcharts, however, are better suited for simple or visually-driven presentations. The choice between the two depends on the complexity of the task, the intended audience, and the need for either textual clarity or visual representation. Question 5. Explain the reasons why there is a digital divide between people with high levels of education and the people with lower levels of education. The digital divide between individuals with high and low levels of education stems from differences in access, skills, and exposure to technology. People with higher education often have better economic opportunities, enabling them to afford devices, internet access, and continuous upgrades. They also tend to gain digital literacy through educational and professional environments where technology use is integral. Conversely, those with lower education levels may face financial barriers, live in areas with inadequate digital infrastructure, and lack exposure to or training in digital tools, making technology less accessible and relevant to their lives. Cultural and social factors further widen the gap. Higher educated individuals often belong to networks where technology is commonplace, fostering adoption and skill building. In contrast, those with less education may experience isolation from such networks, along with a lack of confidence or perceived need to engage with technology. Bridging this divide requires affordable access to technology, inclusive training programs, and community resources that emphasize digital literacy and relevance in everyday life. Question 6. Describe reasons why computer models are used. Computer models are widely used because they are cost-effective, safe, and efficient tools for simulating and analyzing complex systems. They eliminate the need for expensive or dangerous real-world experiments by providing a virtual environment for testing and exploration. For example, researchers can study natural disasters, pandemics, or nuclear processes without risking lives or resources. Additionally, models allow long-term processes like climate change or evolutionary patterns to be understood quickly by compressing timelines. Another key advantage is their ability to manage complexity and predict outcomes. Many systems, such as weather, financial markets, or ecosystems, are too intricate for manual analysis. Computer models simplify these systems, enabling researchers to test different variables, forecast trends, and uncover insights. Their visualization capabilities make it easier for decision makers to understand relationships and patterns within the data, improving strategic planning and communication. Finally, computer models are versatile and scalable tools. Once developed, they can be reused, customized, and applied across various disciplines, from urban planning and engineering to biology and economics. They process large datasets efficiently, providing data-driven insights and enabling interdisciplinary collaboration. By saving time, resources, and effort, computer models have become indispensable in research, innovation, and decision-making processes. Question 7. Explain why personal information should be kept confidential. Your answer must include examples of how personal information can be used if it is not kept confidential. Personal information must be kept confidential to protect privacy, prevent identity theft, and ensure safety. When personal details like addresses, phone numbers, or financial data are mishandled, individuals become vulnerable to risks such as fraud, harassment, or even physical harm. Breaches of confidentiality can lead to discomfort, unwanted contact, and damage to personal or professional reputations. For instance, sharing sensitive workplace information, like medical records or performance reviews, without consent can harm relationships or career prospects. If personal information is not kept confidential, it can be exploited in harmful ways. Cybercriminals might use leaked financial details for unauthorized transactions or impersonate someone to commit fraud. Similarly, disclosing private schedules or locations can lead to stalking or theft. Ensuring confidentiality builds trust and safeguards individuals from potential misuse of their data, making it an essential practice in both personal and professional environments. Complete the data type column in the table by writing the most appropriate data type for each field. For any numeric fields, specify the numeric data type. Question 8b. State and describe appropriate validation checks that could be carried out on data as it is entered into the product database. You can describe different validation checks for the same field. Validation checks ensure data integrity and accuracy in the product database. For number in stock, a range check can confirm values are between 0 and 250, while a presence check ensures this field is not left empty. For location, a format check can verify that the input follows the expected pattern, and a length check ensures consistency, requiring the data to have a specific number of characters. Similarly, the reorder level field requires a range check to validate that values are positive and within a reasonable range, while a type check ensures only numeric data is entered. For price, a type check confirms that values are numeric and can include decimals, while a range check ensures prices are greater than $0. The supplier telephone no field benefits from a length check to validate that phone numbers contain exactly 11 digits and a format check to ensure only numeric characters are entered. Together, these checks prevent errors and ensure reliable data entry across all fields. The remaining few questions will be explained in the next video. Thanks for watching and listening.